Okay, so I told you guys we were going to do another example, right? Here we go. We have a coefficient in front of x squared that is not 1, it's a 3. So we're going to use that VAC chart. To find the b value, I look at what number's in front of x. I see a 20. To find a times c, I multiply whatever number's in front of x squared by whatever your constant is. Got to be careful of that negative. Okay, so then I'm going to take my chart and I'm going to figure out what two numbers multiply to be negative 21 and add to be 20. The only way I can do that is if I go 21 times negative 1. 21 times negative 1 gives you negative 21. 21 plus negative 1 gives you 20. So then I'm going to use those two factors to rewrite my problem. But I'm only rewriting that middle piece. And I'm going to be careful to keep that x there. 21x minus 1x. Oh, I'm going to use these different colors here. Minus 7. So again, I just took my middle term and I replaced them with these two factors. Okay, so I took my I took my 3 terms, changed it into 4 terms. I'm going to turn this into a factoring by grouping problem. I grouped the first 2 terms in a set of parentheses. I grouped the last 2 terms, being very careful to watch that negative. Whatever sign is in front of each term has to stay with that term. Okay, so then I'm going to factor out what's in common there. What's in common for both of those? Well, I see an x, so that's going to get out of there. And then I notice they can be both divided by 3. So I'm going to factor out a 3x. I'm going to divide 3x by each one of those. 3x squared divided by 3x leaves x left over when I divide it. 21x divided by 3x leaves 7. For the next one, I notice that I am pretty close to making those match. The only thing that doesn't match is those negatives. So I'm going to factor out a negative 1 so I can make those signs match. And when I factor it out, I'm dividing each term by that thing that I'm factoring out. So I take whatever's in front and put it in one set of parentheses. I take whatever is being repeated and I just take one of them. And I'm done. Again, if you need to see that again, please rewatch it. Okay, so now we want to talk about factoring with these special patterns. For A, what I notice is that it looks an awful lot like that difference of squares problem. The only thing is that there's something in front of x squared. So I'm going to look and I'm going to say, what is in front of x squared? That's a 9. I'm going to say, can I square something to get 9x squared? And you can. What you do square is you end up squaring 3x. That'll get you that first term. So the only thing that's different here is you got to worry about what else is being squared next to x squared. Okay? Now with that 64, what is being squared? 8 is what's being squared. So I'm going to follow my exact same pattern. It's a difference of squares. I have something being squared in the first spot, something being squared in this next spot. Then I notice it's also a difference. It does not work with a plus. So I take whatever's being squared in the first spot, and that goes first. Whatever is being squared in the second spot goes last. My signs, to get it to cancel, have to be plus minus. Same deal with B and C there. Those fit our perfect square patterns. Okay, so take a second and look at that. Use that perfect square pattern. Find what number is being squared here, what number is being squared here, as I write it in. Then you're going to check and make sure your middle term is 2 times whatever you're squaring in the first spot times whatever you're squaring in the second spot, which we now know is 5. So take a second and try B and C. Be careful of the patterns, and I'll show you the answer in just a sec. Okay, so now let's take a look at B and C. Okay, we said B and C fit our perfect square pattern. So when that happens, I am squaring something to get me to 4y squared. And what I'm squaring there is 2y. I have to be very careful. Remember your exponent rules. If we're saying 4y squared, well, kind of the opposite of that, that means that there was an exponent that got distributed to each of those terms there. Okay, so we have to be careful to figure out what is being squared for the entire term, and that's 2y. And then my middle term is correct. 2 times 5 times 2y does get me 20y. So this is a perfect square pattern. So again, to factor it, I'm going to take whatever I'm squaring in the first spot, whatever I'm squaring in the last spot, and this is a plus plus, so my signs stay as plus plus. Now for the bottom one, I had to do a check with that. I had to say, am I squaring something to give me 36w squared? And you are. 6w is being squared to give you 36w squared. Same for the last spot. Are you squaring something to get you 1? Yes, you are. You're squaring 1. Now your middle term there, is that equal to 2 times whatever you're squaring in the first spot times whatever you're squaring in the last spot? That would mean that my middle term is equal to 2 times 6w times 1, and it is. Okay, so I'm going to take whatever I'm squaring in the first spot, whatever I'm squaring in the last spot, and I notice my signs are minus plus. We're still good there. Remember, that last term just has to be a positive. So I'm going to make both of those negatives. And don't forget, you can rewrite this using a squared sign.